Okay, hello everyone. I'm not used to using a mic, so if I get a bit soft, let me know. Yeah, so I'll be talking to everyone today about the wide world of consent. I was planning on calling it something like Let's Talk About Consent, but got told that would be needlessly inflammatory, so the wide world of consent it is. Also, I know we're about to have lunch, and I promise if you listen to me for the whole 45 minutes, you'll get lunch, and if you stop listening, no lunch for you. So who am I? I'm me, pretty easy. But pretty much I'm from Joburg. I went to Parktown Boys. Then I went from Joburg all the way to Cape Town to go to live by the beach, live that good life. I graduated from UCT with a first-class computer science honors. And then I promised myself I'd never go back to Joburg until I got a job in Joburg. And now here I am. I learned hacking on TryHackMe. I go under the pseudonym of the fluffiest bunny, which I have a great story why I chose that, but not for this talk. And I'm a self-proclaimed funny person, so if you don't laugh at my jokes, I will. And at MWR, I'm the lead of the AppSec service, and I'm a consultant there. I don't know if you guys have recognized the slides from Connor Ortinas yet. And then finally, I'm an ocean enthusiast stuck in a landlocked city. It makes my hobbies a little bit hard, but we try our best. So just some background for everyone, right? So in the beginning, there were kind of two types of phishing that we generally dealt with on red team engagements, right? So the first one is credential phishing. There's someone on the internet that you definitely trust because they're on the internet, and they're saying, please log into your bank, safepark.com, and then once you do, you put your username, password, they get your creds, they log in, they buy themselves some good coffee or something. And then the other one being payload phishing, another strange on the internet. Obviously, we trust strangers on the internet. Please download this safe file and then run it. And run it as admin if it doesn't work because, admin fixes everything. And I will give you many rewards. And they maybe do, maybe don't. But yeah, so we've got credential phishing, we've got payload phishing. And now with the advent of the OAuth protocol and cloud providers and all of that stuff, we have consent phishing, right? So the difference here between the two of them is not we're asking for creds, we're not asking people to download stuff, we're asking for access, we're asking for consent to be given for our application to have access to someone's account. One of the big differences we're dealing with here is that we'll be performing actions as an application. And because we're performing actions in the cloud, not everything has to run as a user anymore, guys. It's 2023. We can get past running as a user. So some things will be executing actions as an application within the cloud. And then as everyone can see here, it says Microsoft nice and big at the top. I will be focusing on Azure for this whole talk just because it's easier to focus on one cloud technology than jumping through all of them to explain things. So the short of it is the quick 1 minute talk, the lightning talk, is a malicious application makes a request to an identity provider for specific permissions to be granted over a user's account. The user then consents to these permissions for the application, and that allows the application to perform actions on behalf of the user within the restrictions of the granted scopes of consent. Now that's a little bit important, and we will touch on that later. You don't just get authorization for everything, unfortunately. And then just quick basics of OAuth. I'm sure everyone's vaguely familiar with it at least, but OAuth 2 is for authorization, OAuth OpenID is for authentication, right? Authentication being who are you, prove your identity, authorization being the privileges you have to perform actions, just that clarity that we sometimes make the mistake on. And this is pretty much what a user is going to be seeing on our flow, right? So a user comes to us, we've maybe socially engineered them with an email, and they access our web page, right? Before the user accesses our web page, what we've done is we have registered our application with the identity provider. So in this case, the identity provider is going to be Azure, right? So we have an application registered there so we can get the necessary things we need to get the access after the user has completed the flow. So user rocks up, they access our application, They click, we want to give consent to your application. They get redirected to their identity provider, which in this case is Microsoft, right? They log in at a Microsoft-controlled legitimate endpoint, and then they get a screen like you saw earlier asking them to give consent. Once they do give consent, they get redirected back to our attacker-controlled domain with an authorization code. There are several other ways this happens, but we're focusing on authorization code today. And then we, being the application, can make a request to Microsoft with specific secrets and that authorization code, and we get granted an access token, an ID token, and a refresh token. So that's just generally the user flow of how we see that there. And so just when does this become consent? When they say yes is kind of when it becomes consent, but you request scopes, it kind of becomes consent when they grant the scopes, right? They consent to giving the scopes. Yeah, and then just a side note that popped into my head before I make a mistake is I know Azure AD has become Entra ID, but I learned this when it was Azure AD. So if I say Azure AD, I mean Entra ID. Sorry about that. And then just, this is good, right? The OAuth 2 protocol is used everywhere, so it's good. And yes, it is good. This is legitimate, useful functionality, right? And I'm not trying to say don't use this functionality, because it is legitimate, it is useful. It stops you needing to give your credentials to a third-party application to be able to perform actions over your account, and it stops you needing to give full administrator privileges to your account to another application to perform some actions. So this is good. But as attackers, what we do is we do our favorite thing. We take something that's good, something that's useful, and something that's legitimate, and we make it good, useful, and legitimate for ourselves so that we can get that access, not anyone else. So how do I get consent? Well, I mean, the easiest way is to ask for it, and that's actually the only way. But in a technical term, first we need an application, right? So in Azure, this is called an app registration. I got a domain, so trustworthydomain.lol, because we need to trust it, obviously. Then I did a web server on EC2 instance and set up DNS. That's very boring. I'm not going to take everyone through that. And then, as you'll see here, I go into an Azure tenant, and I register an application. This is really easy to do. You just go to app registrations, new, you put in the name of your application here, right? Importantly, you can see who can use this API. So if you want to target everyone else outside of your tenant, click the one that targets everyone else outside of your tenant. If you only want to try and consent phish your friends within your own organization, there is an option for that too. And then importantly, at the bottom, there's a redirect URI. It says optional. It's not optional. You do kind of need it. It's optional to put in now. You can put it in later. But just so that we can see, it's trustworthydomain.lol/auth/code, so that I don't get confused with all of the bot scanners on the internet giving me random things. And then I kind of smushed this into one slide, but in the top right there, it says application has been successfully created. This is the easiest way to make a trustworthy application. Sorry, I do laugh at my own jokes. Anyway, so you get to this page, home, app registrations, all very clear when you see it here. I kind of like this with Azure. They tell you what is there. So your tenant ID, which, yes, is public, your application ID, which is also public, and then one step that I haven't shown in my slides that I'm just going to talk you through is if you look on the left here, just below manage, it says certificates and secrets. What you need is you need to make a secret within there that's associated with this app registration. Now, the reason you need a secret is because not anyone can go and pull those access tokens from Microsoft. You need some way to prove that you are the person who registered this application. So basically a password. Yeah, you may see that later. We'll see. Now we create the consent link. You know, the one great thing about Microsoft Docs is they do tell you what you need to do for this to work. The one terrible thing about Microsoft Docs is reading them. So the link kind of looks like this, right? Log on microsoftonline.com. This is very important because that is a legitimate Microsoft login endpoint, right? Makes phishing a hell of a lot easier when you can say, I'm not using a fake domain, this is Microsoft. And then you have your client ID, so your public application ID. The response type is a code, and then the scopes are the scopes of permissions that you want to request. We'll look at those a bit more later. And then for our trustworthy application, it looks like this. Gibberish, GUID, request code, and then directory read write all, because if I'm going to do a demo, I may as well do a fun one. So then we get the user to start the flow, right? So we just say, hi, I'm a stranger on the internet, please trust me. Here's a link, please click this link. It's a Microsoft link, so you can trust it. Your trusted fire end. And they will get to Microsoft. Now, I didn't show everyone a screenshot of the Microsoft login page because I hope everyone's seen that before. But if you haven't, you can just go to Microsoft. I'll show it to you for free. Once you log in, this is the page you see, right? Disclaimer, Jay Fredrickson is my test user. His name is not Jono. His name is James. Everyone seems to think his name is Jonathan. It's James. Pet peeve of mine, sorry. I always feel like I need to say that. And this is pretty much what you see. Now, some important points to note here is you've got unverified, right? And we're going to talk about that a bit more later when we get to responses and remediations for this. And then it also says read-write directory data, read all users' profiles, all of that stuff. Now, you can open those and read more, but you don't need to, because you can just consent on behalf of your organization because Jay Fredrickson is a global administrator user. And then if you click consent, you will give consent to this application. Right? Now, there's some interesting points here. So the slide suddenly got really dark and we lost half of it. That's unfortunate. But not anyone can grant consent to anything, right? That would be a very bad idea. Imagine if a normal user could grant consent to create a global administrator. Not the best idea on cloud. So admin consent can generally only be granted by global administrators or privileged role administrators. There are some niche side cases where other people can do it, but we're dealing with the Microsoft Graph API here, and this is true for the Microsoft Graph API. And there's a huge amount of different scopes that you can request. So there's Microsoft's documentation where they give a list of the scopes and what they do. In this demo, I gave global admin consent to create a user because I'm doing a demo and I want to. But there are a bunch of fun non-admin consents you can get, right? So thinking of this from the perspective of a red team, my slides got more colorful, that's excellent, is firstly, online meetings read write. Why would you want to read online meetings? You do enough of them anyway. Well, I don't know if anyone's been in a meeting where a password's been shared or maybe sensitive information has been shared. Be very useful to read that as a red team actor. Peoples.read, so you can read the contacts of a user. Mail.read write shared. Why would you want to send a mail on behalf of someone who you phished? That would be useful for more phishing. User read basic all, and analytics read. So all the analytics companies can start doing consent phishing, and then they can pull your analytics and sell your data to other people. Yeah, so these are some of the fun ones you get as non-admin. Like I said, there's literal hundreds, so if you want a specific one, you can go look at it. One of the ones I didn't highlight here is files read write, so you can read write files that a user controls. However, a good rule of thumb is that if a normal user can't give consent to it, you generally need admin approval for it. So you can't do things like manage the ownership of files without admin consent, because if that consent can be used as a privilege escalation vector through Azure, generally they won't allow you to give consent for it. However, disclaimer, hundreds, haven't gone through all of them, so there may be some there. Right? So they click consent, they give us consent for the scopes, and we get a nice code here, right? So it's a really long code, so I didn't give the whole URL back, but you can see we can now pull the code from our logs, so Apache 2 access logs, and we can now send that to Microsoft. Right? This is kind of what you're looking at when you want to generate this code. It's not the easiest to read. I know blue on green is not the best color combination either. Tinas has tried to teach me color theory for years and it's just not working. But the blue lines are the important ones, right? So specifically here, we are sending a request to Microsoft. We've got our client ID, so our application ID, and the client secret we generated in that app registration. And then we get an access token, very useful, and now we can use these access tokens to do fun and wonderful things. Right? And the actions we can perform are restricted within the scopes we have, right? You can't just perform any authorization. So when making a request, what you have to do is you have to list the scopes in that request that you need. However, an interesting point that I've picked up from Microsoft here is you don't have to register those scopes, right? You can just add arbitrary scopes to your endpoint, and if a user clicks consent to that, you can request an access token for those scopes. And you'll see why I find that interesting a little bit later in the talk, but it's useful to know. Also, with the URL endpoint, I find it's a little bit finicky, so you can generate it with code the first time, but yeah, you can pretty much add and remove scopes as you want when dealing with that endpoint. So here we have a little bit of a demo, which I just press spacebar, and there it's running, right? So gen.py, right, we're just generating that URL. We're pasting that URL into our browser over here, Microsoft login page. There we go. Logging in as my J. Fredrickson user at globex.lol, one of the Azure tenants I have. On the right here, we can see a lot of bot scanning has happened against my EC2 instance with the logs. I'm entering a very long, very secure password. Consent on behalf of my organization. We can see what we've seen here before, except, wait for a bit. I didn't write a web page for that, I'm sorry, but we do get the code at the top, and the code does show in our access logs at the bottom, right? So you just take the code off screen to a little script you had saved there. You copy paste it into that script, if you copy faster. This is the safe vim. Thanks, Connor. Right, so copy paste it in here. You see we have the secret in there. We have the scopes we're requesting and the code we need. I forgot I had tried out this demo before, and now typing has become hard. There we go. So now we rerun this again. And what you'll see me getting is a lovely access token, refresh token, all of that stuff. It does look a little bit messy right now. You can see the scopes at the very top, what we got. Access token is the part I'm highlighting. Refresh token can be used to get an access token. They expire between 60 and 90 minutes on Microsoft. Just a weird thing Microsoft decided to do. Now, some of us have really useful scripts like create user. You pass it through that access token. You create a trusted friend, because this is the best way to get trusted friends, I found. And then it needs a short, yeah. Cool, so interestingly here, user was successfully created, but authorization denied at the bottom. So you're gonna see me log into the user now. The reason I left the authorization denied in was because it's important to note that you can only perform actions within the scopes you are granted. So because I didn't get the correct scope to get role-based granting to the user, I can't actually grant the user a role in this demo, but it's useful to know that their authorization does actually work. Log in as a new user, right? So I'm logging in as my friend. Made it in the child domain, so za.globex.lol. Very secure password I'm about to paste in. And then instead of repasting it, I'm going to write a password because I want to make this demo take longer. Sorry, every time I watch it, I think of how slowly I type. And here we are. We've logged into our Azure endpoint as a trusted friend. Thank you. If this demo hadn't worked, I really would have thought the tech gods would be against me. Up, move to the side, click again. Right, so let's tell a story of the logs. Do we capture the logical information? So the actual consent grant is logged everywhere, right? So you can log it in your Entra ID audit logs, in the user who granted the consent, in the enterprise applications, all applications, application name, right? In this case being a trusted application or a trustworthy application, my bad. And then we get these lovely logs here. Important thing that we know here is consent was granted by J. Fredrickson to the application, and the scopes are for the Microsoft Graph API, right? Pretty clear here. You can make them a little bit bigger, and then if you make them bigger, you can see in here the scopes that are granted. Now, personally, I would like to see the scopes that are granted in the first set of logs we see. I just think it'll be a little bit easier. And then risky application detected. I mean, giving global administrator consent to an unverified application that's asking to make new users, a little bit sus, I will say that. So that's completely fair. And then you can enlarge all these logs to get the information you need. But the important part here is consent was granted. But what about when we do stuff, right? So this is a specific niche case that I picked up. One of the reasons I started this research was because I had to get into a cloud environment, and then from a cloud environment, pivot onto an on-prem network, right? So on that cloud environment, what I did was I created a user who got granted the role of user administrator. Remember, we got global admin approval, can basically do anything. And I had to do this demo on a different tenant because I didn't have an Azure P2 license on my current tenant. But what I did was I assigned a user outside of privileged identity management here. So you can see the logs here. I've logged in as a trusted friend. We changed password because that's what you have to do when you log in for the first time. But my adding member to a role outside of privileged identity management was actually done by an attacker, not by the application. This specific log is extremely misleading. What happens when people see this log is they go, oh, an attacker, our global admin account, has been compromised. I'm going to roll the password, I'm going to roll MFA, I'm going to revoke all the sessions. That doesn't work here. The reason is because imagine if every time you change your password, all of the applications integrated with your Azure account broke, or you change MFA and everything broke. It's not reasonable functionality that would be dealing with in that scenario. So the only two ways you can really deal with this is option A, you revoke consent for the specific application, and option B, you disable the user who gave consent. Now, generally, you'd give consent to multiple things as the global admin user. I would use probably one global admin to give consent to everything, which means everything you gave consent to has now probably died as well. So it's a fun one, and if you're not sure exactly how to get to it and how to deal with it, it can be very difficult. And then just there in the top right corner, you can see we even get an email telling us it's an attacker's problem. It wasn't the application itself. So very misleading log that Microsoft likes to put out there. But if you do actually enlarge these logs, you do see that it was started by the application we granted consent to. But we can fix it, right? It's not completely broken. Microsoft would never leave vulnerable functionality out in the open and not put a fix in there for it. It's a feature. So the realistic short answer here is no. Can you fix phishing? Not really, or at least not against motivated attackers, right? And you'll see why I say motivated attackers now. So the first way we can do this is we are an admin and we can do administrator settings. Now, to be entirely fair, do not allow user consent will pretty much fix this. However, what it does mean is it means global administrators have to go through consent for every single employee within your organization. Now, assuming global admin is probably someone in your IT team, I truly feel sorry for them if they have to do this in a large organization. So it's not really realistic to always have the do not allow user consent. What is a better one and what is actually the default one is the second one here, right? So allow user consent from verified applications or applications within our tenant. That works until it's a verified application. If I had that nice blue sticker with a check in it, it would be great. My phishing would be so much easier. I'd probably get a lot of great access. However, we'll chat about that now. It's a little bit difficult to actually get that access or just a lot of admin. And then finally, just don't do what I did. Don't just allow user consent. Restrict them in some way, please. I would go for the middle one, the default. Just don't change the setting. The other one is the Microsoft Verified program. So it's a cloud part. To become part of the Microsoft Verified program, you have to become a Microsoft Cloud Partner Program person. This is not a Microsoft selling talk, I promise. This is just explaining it. So you go from a trustworthy application that's unverified to you get lovely tick, and it becomes verified. I haven't looked into signing up for it. I haven't looked into spoofing the sign up for it or anything like that because that sounds like a lot of effort and a lot of admin. And it's kind of out of the scope of what I was really looking at because I could go on a rabbit hole for that for months. So what I would do if I had a black hat on for this is I would rather just compromise someone who is part of the program because it's a cloud-wide thing. So you compromise one tenant who's verified and you can create application registrations that are verified within that tenant. And to be honest, that just sounds a lot easier than dealing with the admin of signing up for that. But obviously, ethical hacker with integrity, I would never do that. Right, and then the best defense, as always, for phishing is just telling your users about it. I've been doing this research for a while. I tell people about it, and they're like, really? I didn't know that could happen. So just having people know about it is the most useful thing that you can have about it. When an application asks for permissions, just tell users to read the permissions, let them know that it could be a problem, it could be very bad. If an application asks to read and write to your mail, ask it why. When TikTok asks all the permissions it asks for, ask it why, and then don't use TikTok. It's all the stuff's on Instagram Reels anyway, guys. And then the most important part here, once users know it exists, is tell them what to do when they make a mistake. Who do they talk to? Who do they go to? What alarms do they ring? Because people make mistakes, right? It's going to happen. I make them, you make them, we all make them. So when something goes wrong, it's not okay if I just talk to Barbara next to me and say, hey, sorry, I gave consent to this application. She's like, oh, that sucks. End of incident. So just let people know what to do when things go wrong. And then with that, you have to have the people, the IT team who knows about consent phishing, know how to respond to this, know that they have to go and revoke the consent granted to the application rather than disabling the person who gave consent or trying to roll their passwords or anything. So as with all of this kind of stuff, knowledge really is just power. And then, yeah, so let's talk of our way through some more practical uses for this, but I'm going to be explaining it through a theoretical context because I like controversies. Also, just side note, a complete black box attack is very difficult for this, and I haven't fully tried it against a company, but my imagination here would be trying to do a complete black box with a unverified application against a large corporate is a bad idea. I would assume that they at least have the default. If not, all user consent has to go through an administrator. So, I mean, it will work against a smaller Azure tenant or someone who's maybe using a SUS plugin from Fiverr, and that person can actually set up their own Microsoft verified application. But realistically, I think this is a very difficult consent to get through. Also, just from a social engineering standpoint, persuading people to click on your link and enter their creds into Microsoft and then give you consent, that unverified badge, while not impossible to persuade people to go past, is a little bit of a blocker. Right, my preferred attack vector here is third-party compromise, right? So you trust your third parties because you kind of have to in many scenarios. So if a third party is part of the Microsoft Cloud Partner Program, which is a mouthful to say, but if they're part of that, you can compromise them. You can get their partner ID or something along those lines. You put it in the app registration, and your app registration is now verified. It's excellent. It's one line. You put it in there, and you get that blue tick that makes everything easier. You can phish so many more people, and added bonus, if you've compromised a third party, you can phish from the third party, and you can have much easier trust going that way, and you don't need to come up with really wonderful domains like safebark.com. I did have something I wanted to add there, and it just flew out of my mind. But I guess the gist of it has been gotten, right? Compromise a third party and then spread your access there. I do remember what I wanted to add. Remember how I said earlier you don't have to register scopes? So what you can do as part of the third-party compromise is you look for the application that consent has been granted to. You add scopes for that application, right? So add whatever scopes you need for your attack. And then the users will have to re-grant consent, right? If you ask for more privileges, consent has to be granted again. But as I said, you can add arbitrary scopes. It's a lot easier to socially engineer through that rather than socially engineering a trustworthy application that no one's ever seen. But like I said, please just trust strangers on the internet. It will definitely go well. I doubt it. And then a lovely diagram, as we can see here, that I'll explain quickly. So in the DMZ, right, your demilitarized zone, you have your web application. Unfortunately, your web application has been compromised. You had a code execution vulnerability within that application, and now you have your attacker sitting within the DMZ on the web app, right? It's talking to a database within the internal network, and the internal network is an internal network, servers, user workstations, databases, all of that stuff. You got your domain controller. Hopefully you don't have ADCS, so it's not one hop to EA. And then interestingly here, we're running AD Connect, so we're synchronizing users on-prem to the cloud. Side note on that, the way trust works for this is the cloud trusts on-prem, but on-prem doesn't trust the cloud. So one of the issues I've had in doing this myself is you can't just create an on-prem user from the cloud. You have to find a way to compromise an on-prem user. So it's just an interesting way with how the trust works. And then on Azure, you have sensitive files, you have MD-ATP, you have our lovely victim, and then you have my spare mask that I definitely don't have and never use. And you have our email, right? So what we are doing here is we send a phishing mail to our victim, right? In the phishing mail, we have the link for the Microsoft endpoint, the login endpoint, with the client ID for the compromised application, right? That is a public ID. You don't have to compromise Azure for that, right? So you have that ID, you add the scopes you want, depending on what they are. So for example, here we're going to say we're phishing a global admin just because it works better for my example. But you add the scopes you want to attack from. Then once the user goes to our web application and they grant the web application that great consent that we've been asking for, the authorization code is going to be redirected to your compromised web server. And also on that web server, you're likely going to find the secret that's associated with the application registration because it needs that secret in order to make the request for the access token, right? So you get that code, you get that secret, you now have access to pivot from a hopefully segregated DMZ zone into your target's cloud environment, right? So the way I got through this, the interesting way I went from cloud environment here to on-prem was I got global admin consent to create a user administrator within the on-prem environment. So I can't create an on-prem user, which does not feel great. However, what you can do is you can reset their password if they've enabled password write back. So you reset the user's password from the cloud environment. Once you have that password, you make it more secure because password 1at is not a secure password. And we're actually doing the user a favor here. So you make a more secure password for that user, and then you can use their credentials to log in onto the on-prem domain. Another side note here, password write-back sucks. Please don't try to use it. It is very unreliable. And when you have to try to use it within a specific time frame, it is extremely painful. I've had very stressful encounters with password write-back trying to get it to work, running it, and I can see someone nodding there. You know the same amount of pain. Yeah, trying to run it 20 or 30 times, not getting a single write-back connection error and server error. But when it does work, it works beautifully. Yeah. So is the world burning? Not from this. So it's important to know this exists. And as a cybersecurity consultant, it's not realistic for me to actually exploit this in an assessment, right? Because a lot of the paths I've outlined are more black hat paths rather than cybersecurity consultant paths, which is why it's important to know it exists, right? It's not something that we can necessarily easily test for as a cybersecurity consultant, but it is an attack vector that does get exploited in the wild by threat actors. So it is important to know that it is around. And I feel like I missed something on my notes. I'm just scrolling down quickly. Yeah, so just teaching your users the red flags for untrusted applications. If a application is telling you it wants to read your spam mails and delete them, and then is then asking to create a user, not a good application. I don't recommend giving consent to that. Other technologies, right? So I've looked into some of them, and to be honest, it's a mixed bag. Google looked pretty good from what I've seen so far. However, I think the most important thing when it comes to defending against consent phishing is this is legitimate functionality, right? You can't get rid of it, or at least you really shouldn't, because it's very useful and it has more of a benefit to security than it has a drawback. The important part here is how difficult it is and how much verification goes into the verifying of whoever signs up for your verification program. So I imagine Microsoft is probably quite intrusive and asks for a lot of details. But I imagine the IDP I set up the other day may not ask for as many details. If you give me $100, I'll give you a blue check mark. So the amount of effort that goes into the showing an application is verified and unverified is important, and then just showing the application is unverified. So we saw here on Microsoft they had a little thing that just said unverified. Google shows you a page, and they're like, don't trust this guy. Once again, I haven't looked into how hard it is to sign up for sign up for Google, so I don't know how that balances out. But just knowledge and looking at red flags and thinking, which can be very hard for me, is all you need to generally defend against this in a good context. Yeah, and then just some acknowledgements. So thanks to MDubs for providing me time and support for my research. Specifically, Chris back there, I've asked him a lot of questions. He QA'd a lot of my content for this. Tinas for pointing me towards the topic in the first place when we were having a discussion, and he's like, "Oh, have you heard about consent phishing?" And my answer was, "No." Now I have. Jacob Simmons, who's not here today, but he wrote a lot of the scripts that I've used in this presentation, and when we've used this attack vector in exercises, a lot of the Python finicky scripts, I had the broad idea, and he helped me out in doing the actual implementation. And then just for everyone here, thanks for listening to me speak. It's always great to have 30 to 45 minutes of people listening to my voice, because I do love speaking. Any questions? Yes. Sorry? So there have been some very high-profile attacks with this, right? So there was a famous application called the upgrade application that just said, "We upgrade your RAM," or something along those lines. And they got very far. With admin consent, it's actually become quite difficult. This hasn't happened a lot in South Africa, or at least it hasn't been reported on a lot in South Africa. There's a lot of interesting cases in America about this. I wouldn't say super common, mostly because of the difficulty of getting to that verified badge. Somewhere like America, I'm assuming they're doing admin consent to pretty much everything, so you do have to have that verified badge, or they'll at least have the default. Yeah, so not the most common because of that difficulty, but definitely is being exploited. Yeah. Justin? Yeah, it will. So to revoke the consent, pretty much what you go is you go to enterprise applications in Azure or in Entra ID, and you delete or disable the compromised application or revoke all the scopes granted to it. Microsoft, not Google, does actually check against those scopes granted to it before it allows you to perform an action. And it's actually pretty efficient. It's, I think, the fastest I've seen it. Well, it happens pretty much instantly, because I did the attack like 2 seconds after I revoked consent one time. Didn't let me do it. So yeah, very good on that side. Yeah, so for admin consent, you have to grant consent on behalf of your organization. It's not necessarily just enough to do it as a global admin, though to be fair, that setting has been a little bit finicky when I've been researching this. Generally, it's grant consent on behalf of the organization. If you're a user, obviously you can't grant consent on behalf of your organization, so if you do click that, Microsoft just tells you you can't do this. It's like, you don't have enough privileges, go back and untick it. Yeah. Anyone else? Awesome.
Thank you.